where you can able to record the image and the image quality is good. This is the reason for developing the conventional fluoroscopy into image intensifier fluoroscopy. The image intensifier converts the X-ray visible light as same as the fluorescent material at the higher intensity than the conventional fluoroscopy scale. So the image should be visible under normal lighting conditions. So you don't need the dark room, where you can see the images in the normal light room. Then the greater image brightness, so you can able to adjust the brightness of the image. They are providing the option for recording. So you can record the image for future diagnosis. What are the components of image intensifier fluoroscopy? First, X-ray generator for the current production. Selection of KVP and MA parameters. The KVP parameters are selected. For the constant power supply, we are using the X-ray generator. Then the X-ray tube for the production of X-rays. Same as the radiography equipment. The fluoroscopy is also having the same parts like anode, cathode. It's a rotating anode X-ray tube. Then the collimator for the collimation of the region of interest. And filtration. So what is the filtration? What is the function of filtration? Note it. The filters. Wait. When the X-ray from the generator and the X-ray tube, it contains both low energy and high energy. It will have a low energy X-rays and high energy X-rays. What say? Where low energy X-rays passes through the patient and absorbed in few minutes. That is low energy patient pass can't. It will absorb in the patient's body. So if the image is not formed. When it is having higher energy, it will pass the patient and produce an image. It will affect the detector, then it will produce an image. So low energy is increasing the patient dose. So in order to remove the low energy X-ray, we are using a filtration. So the filters remove the low energy X-rays and only use the high energy X-rays. Understood? Only high energy anumadikum. It will remove the low energy X-rays. So the filters used to increase the quality and the quantity of X-ray energy. That's it. Then the table, patient bar is placed on the table. The table is made up of fluorescent material which is called as carbon, and it can able to move front and back, up and down. Then the grid. So what is grid and what is the function of grid? The grid removes the scatter radiation. Very same. When X-ray passes the patient, it will produce it is a primary radiation. When it enters the patient, it is a primary radiation. After entering the patient enter on but to reflect down. That is scatter radiation. So in order to remove the scatter radiation, the grids are used. So the grid function is remove the scatter radiation. Increase the image quality. Then the image intensifier, which is used to convert the X-rays into visible light. And the spot film camera, which is used to record the image, and optical coupling, where the lenses are fixed. So in using a camera, we should use a lens. So the lenses are fixed due to optical coupling. In video camera, where the images are recorded, the monitor for the examination of diagnosis, where you can be able to see the radiologist or everyone can be able to see more than 4 or 10 numbers through the monitor. So there was 2 types of X-rays. X-ray to be used under the patient, then above the patient. We can use here both X-ray tubes. It contains the fluoroscopy unit contains both X-ray tubes. where the X-ray tube is placed under the patient. You can also use the X-ray tube which is above the patient. So what is mean by image intensifier? This is a component, right? The image intensifier, it is an evacuated glass envelope which is vacuum bottle. So what is the reason for making the tube in vacuum? In order to make the X-rays do not disturbed by the air. It will be air present only. If the air is present inside the vacuum, inside the glass envelope, the X-rays will interact with the air. So image data should be erased. So in order to maintain the vacuum, we can increase the image quality. அதான் X-ray வந்து பாஸ் ஆகிட்டு வரும்போது இந்த வேக்யூமில் வந்து ஏர் இருந்ததுன்னா அது வந்து ரியாக்ட் பண்ணுறதுக்கு வந்து ஏர் உள்ள ரியாக்ட் பண்ணிடும். இமேஜ் வந்து ப்ரொடியூஸ் ஆகாது. இது வேக்யூமில் போட்டால் the air உள்ள there is no air. If it is in a vacuum, so it will not disturb. அது டிஸ்டர்ப் ஆகாது. So the main components of image intensifier are intensifier screen, focusing electrodes, then the anode and output phosphor window. So let's discuss about the components detailedly. Glass envelope. It is made up of lead, which covers all components of thickness 2.4 mm. And maintain the vacuum inside the device. So the glass envelope, which is made up of a lead, protects the components and create a vacuum. Then the input screen, it has 3 layers. Aluminum window 1 mm, made up of aluminum, support the input phosphor. So this is the vacuum window where the X-ray enters the vacuum through the window. Then input phosphor, which is made up of cesium iodide. It's a photodiode. Converts the X-rays energy into visible light. So the cesium phosphor, which converts the X-rays energy into visible light. Then the photocathode, which is made up of antimony cesium, which converts the visible light into electrons. So when the X-rays pass through the vacuum window, it will reaches the input phosphor. Then the X-rays converted into light photons, visible light. Then the visible light is converted into electrons by using a photocathode. This is the 3 components of input screen. So coming to the next component, focusing electrode, which is positively charged. So you have to give a constant power supply to the focusing electrodes. And the electrodes வந்து நீ power supply கொடுக்கணும். In order to accelerate the electrons towards the anode. Anode கிட்ட மூவ் பண்றதுக்கு வந்து electrons வந்து constant power supply கொடுத்தாதான் அது வந்து accelerate பண்ணும். electron வந்து மூவ் பண்ண வைக்கும். So it's accelerated. Then the accelerating anode, which is made up of aluminum, attract and accelerate electrons toward output screen. அதில் வர electrons வந்து output screensக்கு வந்து move செய்யறது வந்து anode. Then the output screen is silver activated zinc cadmium sulfate, which is made up of cadmium sulfate, converts the electrons into light photons, which converts the electrons into light photons. So this is the component of the output screen, where the electrons from the input screen and focused by using the focusing electrodes, the electrons move towards the anode. The anode moves the electrons, collect the electrons and move towards the output phosphor, which converts the electrons into visible light. Then the light is sent to the output window. Then it will send to the ADC, analog to digital converter. Later the digital image is produced. What are the limitations? So if we are having an advantage, some limitations does have. The unit is larger in size, so the image intensifier should be in bigger size. There is the air leakage in the vacuum. Image intensifier tube, the vacuum is destroyed. resulting in degraded image quality. So if the air inside the image intensifier, it will degrade the image quality. அதுக்குள்ள ஏர் ப்ரெசென்ட் ஆயிருக்குன்னு சொன்னால வேக்யூம் மெயின்டைன் பண்ணுறோம்ல, ஸோ அந்த வேக்யூம் வந்து டிஸ்டர்ப் ஆகிடுச்சுன்னா இமேஜ் குவாலிட்டி வராது. Then the voltage of the electrodes is not correctly adjusted, the electrons will not reach the focal point. It is called as defocusing effect. So நான் சொன்னேன், the focusing electron வந்து constant power supply. You have to give a constant power supply to the focusing electrons. அதுக்கு நீ constant power supply கொடுக்கலன்னா it does not move the electrons towards the anode. அந்த anode-க்கு மூவ் பண்ண வைக்காது. So you have to give a constant power supply. Then the television system depends upon the raster length and bandwidth frequency for spatial relation. So the bandwidth of the image light photons, which is from the image intensifier, and the video camera bandwidth should be same. So if the bandwidth is not same, the spatial resolution should be yet low. Then on additional, in mammography we are using a automatic exposure control. In fluoroscopy we are using automatic brightness control. There is a relay feedback circuit which measures the light intensity of the output screen or video signal. That measures the signal. And the intensity image intensity measure பண்ணும். And measure பண்ணி if the image intensity is higher or lower, it will send the message to the generator. Then the generator adjusts the KVP and MA automatically. So by adjusting the KVP and MA automatically, you can reduce the passion dose. Additionally, the brightness is also adjusted by using the automatic gain control. Alternatively, the brightness of the image on the monitor can be adjusted by varying the gain of the TV system, which is called automatic gain control. So the KVP and MA is adjusted by reducing the value. It will reduce the passion dose, and you are visualizing the image in the monitor. So brightness should be higher. And if the brightness of the image and the screen should be same, you can't able to see the image.